So, in the previous lecture 6.1, 6/1, we had a background of machine learning, various approaches, and now in this lecture we will discuss the learning approaches. As I mentioned you what we mean by supervised learning, unsupervised learning, and the reinforced learning. Little bit of detail in that, so that we are approaching this subject of AI/ML and PHM in a very elegant way. So, let us say, as I mentioned, don't you think it is it looks like a neural networks where neurons are connected, and in frontal area we take our decision making. I will not go into the detail. We have a semi-sensory, this sense organs are being processed here. Then your optical system, occipital region, this is over here, and here there is a highway to our nervous system that gets connected with the body part, and that is what our neural network does. Neural network does. So, where the role of neurons is it is a you can say fundamental building block in the brain. As you can see here, in here also we have this training and deep learning which is happening due to neuronal communication, supervised learning, unsupervised learning, reinforced learning, and probability theory in learning. Probably this will be taken to the next lecture, because it is a vast topic. It will require 2 lectures, but we will make the beginning in some sense or the other actually. And now let us see what is supervised learning. In short, if you tell me, for data in which for different streams or vectors the label is available, then we use the supervised learning approach, because supervision is done where you know the rules and regulations and labels, what should be what. So then it is like a mirror which is indicating that this is the color, this is the data, this is the stream that is there, which you can infer the information. So in supervised learning, labels are there for the data at the outset itself. And what we do is we train the neural network in identifying these labels. So it said here we need associate label for various pattern that we are reflecting on the input layer actually, are inputting at the input layer. And supervised learning has only effective algorithm in pattern identification or pattern recognition, from the data set that is available to us. And one of the advantages, learning can be defined as a machine learning approach where the algorithm learns from the set of input vectors or stream of. Now, once I have given an input, once I have given an output, which one is associated with what? That means I am like a supervisor. I have created the framework and I am giving it. That is what happens in the machine learning. The input could be anything, but it should be presented in a form which can be comprehended at the level of binary signal, combination of signal. And even if it is a analog data, it has to be converted into digital data, and then that can be processed at the input node. Now it could be any image comprising of many pixels, and each pixel must be comprising of many neuronal combinations and pattern, a set of characterization. It could be data vector, symptom, disease, depending on what the characteristic is. So we know that if there is if particular color, based on the color or texture of human body, if you want to say this disease has gone to this level, level 1, level 2, level 3, so that can be done using ANN based on the expert opinion. Domain experts are key, and their modeling implementation is key to success of any intelligent system. And I think now at this point of time, this fact has been well recognized. There are two major supervisor learning: classification and regression. We will be seeing these tools. Okay. So now let us see, try to imagine what is a supervised learning. The inputs are A, B, C, D, X, Y, Z, whatever, and then output is A, B, C, D is X, Y, Z. Okay, input, training, and output identification is X, Y, Z. So all characters have to be identified. So this is for the simplicity. I am giving this example. Now we present, let us say, 5 vector comprising of 7 nodes. It is a practical example. Let us say this is just for the sake of training our ANN for A, for B, for C, for geometry or whatever you may call, and that should be so it is basically labels are there. For A there is a label A for this. So that means if any sentence is made of A, B, F, G, so it should be able to A, B, F, G should be able to identify. Okay, and when I do the recall test here to the machine DAY, I am not giving in a line this data. So DAY, day, is identified and results are okay. So this is called recall. In some patterns we use whatever patterns are available. Some patterns we use for performing recall tests. Suppose if I have a data set of n number, so n minus 10 or 20 we use for training, and 20 data 20 is just a random number I have picked up. 20 is data they are used for performing recall test, because those things have not been used for training. So we want to know whether my ANN performs okay or not. The example is this case. There are some alarm windows. 0 is alarm off, 1 is high. So this is one pattern, this is second pattern, and they are all comprised of 7 windows, 0, 1, 0, and different combination. Now I have trained my neural network that P1 will be X, P2 will be Y, P3 will be Z, and next 2 will be PQ. So if this system comes, we should be able to, so vector or pattern P1, P2, P3, P4, 5, and corresponding output is X, Y, Z and all that. If I am able to identify so what are these X, Y, Z, and they are different from this X, Y, Z, PQ. They are basically label. For this P1 label is X. For P2 the label is Y. And now I will train my neural network. Okay, and it could be any X, Y, Z. Just we have given for illustration. I am home, I am not home, I am on first floor. See, if whatever you want to say, or in terms of condition, you can say it is a normal condition of the plant. It is basically power failure condition of the plant. It could be some particular deviation in the plant, or so these labels need not be X, Y, Z. It can have its own expression also. So based on the trip and alarm coming to the control room, I have given this expression, and that is how we trained the neural network. And if I have X pattern, like suppose if I have shown 5 pattern, that means I should have had 7 patterns, and those 2 patterns, remaining 2 patterns, randomly I will be using it for recall test. That means my based on this training, my ANN or my machine learning algorithm should identify those things also. So in nutshell, how neural network it works, or machine learning algorithm. When I say neural network, machine learning, deep learning, they also mean the same thing. Only thing is, in deep learning we talk about only ANN models. So I have just for simplicity we have taken this 7 and 5 pattern. But when you have the modeling for the complex plant, you can have more finite number of pattern and associated finite output. Okay, and ANN has to be trained, or machine learning algorithm has to be trained. But that story doesn't end there only. Once I have identified, let us say Y, now my domain knowledge, what is to be done for this condition, that starts, and that can be either a rule based system or fuzzy rule system. So that will lead to the management. Here I have done only identification, okay, or I might use small ANNs even for prediction of the particular action that need to be taken. Okay, so the previous example, the 5 patterns, I have uh, I have exposed to one ANN model, the algorithm here. So there are 2 nodes here, and the data is coming in over here, and 1 node for presenting the output. So what I have done is, these nodes, as I mentioned in the previous slide, training labels X, Y, Z and all. So ANN has been trained to identify these labels, and from this only some one is I can do ideally recall test on this trend pattern. So the ANN should be successful in identifying all the 5 patterns. That is part A. The 2 patterns which I have left, even that also it should be able to identify, and there this online prediction is, so one is training, this part is called training phase, and this is called operational phase. When it is operating, so online prediction occurs, that or we are doing, I am doing a recall test. So trained system comes into the picture, and then it can identify vector P3 as a plant condition, or so here it was a P3, that condition online signal from plant was 1001001. So P3 you will see 1001001. So it was in real time operational phase, that is real time, it was able to identify this, and I think it has done a big job, because by the time this patterns, they immediately get reflected into the control room of the plant, and it has immediately almost spontaneously it has predicted, and it is a big thing because now operator has a friend in control room which supports his decision, and it is a big thing. Like a pilot, he is in trouble, and then based on the condition, we have developed a AI model, and the system itself has predicted something, and it has informed him this condition. Now he has to endorse it, and the action can be very positive. Some aviation accidents, you find that correct or wrong action was taken. Correct action taken are all appreciated, but those correct action, they were not part of training and all that, because it can happen unless until the situation is conceived, it doesn't form part of the training. But then the operator can think even beyond that. So operator took a correct decision, and his action saved life in aviation. There are movies on this system, but at the same time, due to shortage of the time, and then the pilots were able to demonstrate in the accident I am referring to, demonstrate that they had only very small time. So that means the question doesn't go to machine interface. There are some controlled or uncontrolled parameters wherein he did not get sufficient time, because some time goes in in communicating with the control tower also. So if you remove that time, even though we have simulators and all that, probably I am talking about very deep deeper situation, but there should be appreciation that it is not the human always. There are some constraint with which sometimes it takes correct action, and sometimes it is not possible. So we have to have a retrospect on this kind of thing and improve our system. But one thing is there, the intelligent system, they provide a feedback wherein operation is the operator has choice to accept or to reject the prediction and accordingly take action. Now there are some supervised learning approaches, as in when time comes, like k nearest neighbor test. ANN alone, it's a module. ANN can fall in both the categories, like supervised and unsupervised learning also. There are some methods which are not working in supervised learning, but they are meant for only for unsupervised learning. Now decision trees, regression methods, this also will see what we are calling regression is again an iteration procedure, random forest, Bayesian, and there are many, or KNN, it is called, K nearest neighbor. So some of the things I have listed because these are very popular algorithms. There are many more and all. And so That is what we have got now, a comprehension of supervised learning. In one word, if you ask me, where labels are there, so supervised learning is good. Now let us see a second part, unsupervised learning. Unsupervised learning, there are no labels, but based on the characteristic or features or association of the random node with a typical node and forming a cluster, because unsupervised learning, either it is classification, cluster formation, or categorization. These are the things they are associated, because from the huge population of data, we want to understand which 4 or 5 category this particular system belongs. So the particular random data belongs, and that at digital level can be done easily, provided the algorithm is very effective and the feature extraction are done properly. Supervised learning is category of AI. It identifies patterns, okay, in the data set with the objective to bin the data. Bin means categorize the data or pattern into one category or second category or third category or fourth category. So this is basically classification and categorization approach. Wherever you have this kind of system, many times in life we have from the quantum of data that is available, and we want to classify, and which is not possible, humanly possible, but a computers or a AI tool can do it very easily. So the data is not having label, you know. So the one thing which is very inherent part of unsupervised learning, and it does not require supervision also, because once you have developed a tool, given the feature, might be it if it is an industrial setup, it will keep segregating the things and all that. The way we do mechanical segregation on for the data, it can be done at digital level also using AI algorithm. So let's say one of the example is, we have data sets, but there are 1 or 2, 3 data which are outlier, which doesn't it has come by somewhere or the other, but and it has formed the part of the data also. But looking at the visual, like suppose if there is some outlier, we can visually we can see it, and but then we cannot keep doing online and all that when data is flowing very fast. So selection of outlier, we have to give just boundary of the system, and outlier will be eliminated from the rest of the data. And of course then some testing can also be done for this kind of situation. So outlier identification becomes much easier. And then generative AI models can be categorized as unsupervised learning, because they generally it so happens that generative AI has been used for supervised as well as unsupervised also. But here it is like, predicting the it is like, reproducing the many output of the certain type. So it depends on the characteristic, a certain characteristic. So if you want to see optics of this, how it works, then this is a sketch. Input data, you can see random data is there. Just for our understanding, we have made it red, blue and green, but sometimes the features are not so distinguishable, because we want to give a demonstration. So this is a classical example of unsupervised learning. We have not given any label, but we are categorizing like a mesh, it does. If it is a micron mesh, some fine particle will go out of that, some big particle will come out. Something like for what is there for mechanical, here it is done at the AI level or at digital level. So algorithm along with pre-processing, and so what has been done here, giving color itself is making it more prominent. So some pre-processing and feature extraction has been done. It could be round, it may not be exactly round, it may be trapezoidal shape, or it may be rectangular shape. Those kind of things you have to feature extraction we have to do, and we have to for that you require a domain expert to create those features, and based on that filtering occurs. And that is how on mechanical level you would have seen in very factory like ecosystem how the objects are segregated. Not exactly, but it is similar to those kind of things. The red balls have gone into one bin, and the green balls, and then yellow, and then indigo, and then blue balls. So all this segregation has taken place, and this is the very effective example of unsupervised learning, because we have not We could have done it with the supervised level also, but in online mode, it was considered appropriate that let us filter it out like this, and do not give pattern. The pattern will form on its own. Okay, I can say always I can make a supervised learning model based on this pattern actually. So, but the industries, they have chosen to do it like this because there are some purpose. So the purpose itself becomes predominant in deciding which supervised or unsupervised learning you should have. So at the end of the day, the unsupervised learning is used for clustering, data size reduction, identify outlier as also anomalies. So here is this thing, and now unsupervised learning algorithm, cluster algorithm, and then there are three: associative rules and dimensional reduction. Okay. So the cluster algorithm, it involves a group of unlabeled data, and the objective function is to eventually similarity. Okay, similarity of the data based on size, shape, color, physical properties, chemical properties, images, etc. And for binning the objects, we have seen in the previous slide. For example, one of the popular k-mean clustering. Okay, k-mean clustering, and similar other methods applying other attributes. Then associative rules implies example. That means of feature using production rules. So that means here we are forming production rule. It could be crisp or it could be fuzzy rules we have formulated. And fuzziness means if my input data is in the form of linguistic variables. Okay, so quantification is not possible, but using fuzzy logic, we find out the fuzzy means imprecise information. So if that information or data was imprecise, I'll apply fuzzy logic. The fuzzy logic defuzzify them and again make into the crisp thing. So that output, they are centroid and so many other things, and then membership function also rectangle. Various functions are there, triangular or trapezoidal. So those kind of algorithms we have to use for association of data, and then dimensional reduction. This is a purpose, like even in feature extraction, and we use what we do pre-processing. We reduce the dimension of the data. Involves reduction of complex in terms of size and variability features, database to size, effective for analysis. So by filtering out less significant attribute and retaining the vital one. So this applies to even feature extraction also, this technique. So these are the unsupervised learning algorithm. Three major categories we have seen. There could be many more in this area. So now the last one is reinforced learning. It's very important and a lot utilized. We are doing the same job, a mix of this thing, but here there are four main element of this. One is environment. Environment means we can have a company policy. Let's say it is operating in a company environment, industrial environment. Now company policy and all, they decide like environment from business objective policy. Then the second thing is action. Okay, action is there and the agent is there. So action will be performed by agent. Okay, and then agent has got something, and then finally it will reflect on reward, whether there will be environment will work out a reward, action and then reward. So action and reward, they are the essential feature around the environment for reinforced learning. Okay, and this whole state approach operates in a simulating environment. Okay, so these are the reinforced learning feature, and here the module is unsupervised module. You can see here from this data. So if systematically if we go on understanding what is a reinforced learning means by reward we are reinforcing the right or wrong action. Okay, so if it is a right action, it will be rewarded. If it is a wrong action, it is otherwise round, and it operates in a simulation environment. Reinforcement learning refers to a mapping from situation to action in order to maximize a scalar reward or reinforcement criteria. Whatever is our reinforcement criteria is there, that will be a deciding factor for reward or no reward. As discussed earlier, there are four major, I mentioned agent, action, and finally simulation. Environment, agent, action, and simulation. These are the four intrinsic element to reinforced learning. The action is not specified. However, the emphasis is on discovering which action gets highest rewards. Okay, so you can take any action can be taken by agent, but agent can take any action to reflect on the environment, but it is determined by reward. Okay, so final output decides what kind of action it was taken. The state and reward are inherent to dynamic distribution in reinforced learning. Obviously, there are four major variations of reinforced learning depending on this thing: policy based, value based, model based, and hybrid approaches. Because how you will decide the reward. Okay, so these are the four elements, and this is a short description of reinforcement learning. So here of course these three literature, one is the book by Professor Pat and Kang at University of Maryland, that is the Prognostics and Health Management of Electronics. In fact, this lab is CALS, Center for Advanced Life Cycle Engineering, is working on electronics PHM. Okay, and good work has been shown, and this is one of the pioneering lab in the world as far as the application of PHM is development of tools and application is concerned. There is some website I use some not figure exactly, but inspiration sort of thing we are taken from there. And then there is a book on intelligent fault diagnosis and prognosis for engineering system, Wiley. Because what happens, AI is relatively new field compared to any other thing. So resources are not less, but I would say very limited, but very important. So if you have to see the state of the art thing, so you will find that this book is 2018. This is of course pretty old book, and this website. So any lecture has to be connected to the state of the art situation, for the sake of completeness. So with this, now we'll go into the probabilistic method in the next lecture. So now I'll provide overview of the lecture 2 of week 6. One of the core characteristic of deep learning is that artificial neural network is at the core of deep learning. Okay, in machine learning it is all statistical method, probabilistic methods, but then in the deep learning, ANN has got a major role to play. It doesn't mean that machine learning statistical approaches are not used. They are also used, but ANN plays the lead role here. Machine learning things, mostly they are probabilistic, and many algorithms are there. What we saw, are selected few, but there are many more. And at the outset, both machine learning and deep learning, there is a considered overlap. Therefore, they are collectively referred as the AI / ML / DL. Okay. In learning algorithm, we have seen the supervised learning, unsupervised learning, and reinforced learning. Their typical characteristic their typical application, potential applications, and the kind of overlap they have with rather supervised or unsupervised will not have, but some time in the data or feature extraction, at input level and all, they might have some overlap, and the reinforced one, we found that it is like a unsupervised technique. The example at least that we presented. Here we three major categories. There are quite a few more also, but our scope of this lecture, we decided to discuss the major approaches, and that is supervised, unsupervised, and reinforced learning. And then there are many models and methods and all that will be discussed in the next lecture, and that is, they are called probabilistic methods, or then there are also parametric, non-parametric, that we'll discuss in week 6, lecture 3.